A pharmacist is to prepare 15 milliliters of a special eye drop for a glaucoma patient. The eye drop solution must have 2% active ingredient, but the pharmacist only has a 10% and a 1% solution in stock. How much of each type of solution should be used to fill the prescription? So to begin, we must set up a system of linear equations. And we know that each of the solutions, when added together, must result in 15 milliliters. So this first equation represents the amount of milliliters in each. Then we want to also represent each of these using the percentage of the special eye drop active ingredient in each. So in our X solution, we have 10% of the active ingredient. So we can represent 10% by 0.1x. So that shows us that 10% of the X solution is active ingredient. Plus, in our Y solution, we have a 1% active ingredient, or 0.01. And we know this equals the 15 milliliter amount, and we know that the total active ingredient in that one will be 2%, or 0.02. So now we have our system of linear equations, and we want to solve the system using substitution. So let's make this first equation equal to y. So we have y equals 15 minus x. Now we can substitute the 15 minus x in for y in this second equation. So we have 0.1x plus 0.01 y, but y is, we know is 15 minus x, equals, and 0.02 times 15 equals 0.3. Now to simplify, we're left with 0.1x plus 0.15 minus 0.01x equals 0.3. So combining like terms, we get a 0.09x plus 0.15 equals 0.3. So 0.09x equals 0.15, and x then equals 1.67. So now we want to find our y. So we plug this x back into one of the equations. So we get y equals 15 minus 1.67. And we know y then equals 13.33. Now, we need to make sure that we know what x and y are representing. So if we look back at this second equation that we wrote, we had x matched up with 0.1, and that 0.1 represents the 10% solution. And our y was multiplied by 0.01, so that must represent the 1% solution. So the correct answer would be C.